Good day. In this video, we will talk about lipids, specifically the omega-3 and omega-6 fatty acids. But first, let us define what lipid is.
Lipids are fats and fat-like substances that are hydrophobic, meaning they don't mix with water and are essential components found in oils, waxes, and cell membranes. Among the most important lipids are the omega-3 and omega-6 fatty acids, both of which are essential and must be obtained through your diet. Now, let's talk about the omega-3 fatty acid, docosahexaenoic acid, or DHA. DHA has a molecular formula of C22H32O2. These are sourced primarily from cold water fatty fish like salmon, mackerel, tuna, sardines, and shellfish. They are vital for fetal and childhood development, maintaining cognitive function, supporting retinal health, and providing anti-inflammatory benefits crucial for cardiovascular health. In contrast, omega-6 fatty acids like linoleic acid have a molecular formula of C22H18O2 and are widely available in vegetable oils, nuts, and seeds. Their main roles are acting as a structural component of cell membranes. It also functions in the production of eicosanoids, which helps regulate inflammation and other bodily processes.
So moving on to their hydrophobic and hydrophilic regions, the functional group and their active sites. So first is the omega-3 fatty acid or DHA. The hydrophobic region is the long hydrocarbon chain. This part is made of hydrogen and carbon atoms which is nonpolar and repel water. Because of this, the hydrophobic region helps DHA mix well with other lipids in cell membranes. On the other hand, the hydrophilic regions is found at the carboxyl ends which contain the carboxyl group or the COOH. This part is polar so it can interact with water or other polar molecules. The main functional groups in DHA are the carboxyl acid group and the multiple carbon-carbon double bonds. And for the reactive sites, it has the carboxyl group which is the site for esterification and the double bond which can undergo oxidation or hydrogenation. Next, let's move on to the omega-6 fatty acid or the linoleic acid. It has 18 carbon atoms and 2 double bonds. Just like DHA, the hydrophobic region is the long hydrocarbon which is nonpolar and repel water. Meanwhile, the hydrophilic region is the carboxyl end, and this part is polar and can bond with water or other polar molecules. For the functional groups, linoleic acid also has the carboxyl acid group and the two cis double bonds. These double bonds create bends or kinks in the molecule, making it less tightly packed. That's why unsaturated fats are usually liquid at room temperature. As for the reactive site, they are same as the DHAs. The carboxyl group which can form ester linkages or ionize and a double bond which is reactive to oxidation and hydrogenation.
Omega-3 and omega-6 fatty acids are essential lipids that our body can produce, so we get them from foods like fish, nuts, and vegetable oils. They serve as major energy source stored in our fat tissues and broken down when our body needs fuel. They are also important in cell signaling. Omega-3 and omega-6 produce eicosanoids, which are molecules that regulate inflammation, blood pressure, and immune response. Also, they help maintain membrane structure, keeping cell membranes flexible and allowing nutrients and signals to move properly. Lastly, they play a key role in protection, keeping skin healthy, and safeguarding organs.
So now I'll be discussing the applications of omega-3 and omega-6 fatty acids in medicine, food, and material science. So these lipids are not only important for our bodies but are also valuable in many industries, promoting health, improving food quality, and creating eco-friendly materials. In medicine, omega-3, especially DHA, is used in supplements to help manage heart disease, brain disorders, and inflammation. It supports brain function and protects nerve cells. while linoleic acid, it is an omega-6 fatty acid that is also used in skin creams and wound healing products because it helps repair cell membranes and keeps skin healthy. In food naman, DHA is added to infant formulas, milk, and health drinks for brain and eye development, while linoleic acid is found in vegetable oils like sunflower and soybean oil, improving texture, flavor, and nutrition in foods such as yung margarine and yung baked goods. Lastly, in material science, these fatty acids serve as eco-friendly raw materials for biodegradable plastics, cosmetics, and drug delivery systems, supporting sustainability and innovation as well.
And for the ethical issues, omega-3 and omega-6 fatty acids offer many health benefits, but their production and marketing raise ethical concern about the environment, honesty, and consumer safety. Fish oil sources can contain toxins and cause overfishing, harming both health and marine life. Making plant-based or algae-based alternative is more sustainable. Some companies also make misleading claims about these supplements, which can deceive consumers and promote unhealthy dependence. Additionally, oxidation during processing can produce harmful compounds, so manufacturers must ensure product safety and quality.
So, when we talk about omega-3 and omega-6 fatty acid, we're really talking about good fats that our body needs but can't make on its own. For example, omega-3, especially DHA, is found in fish like salmon or tuna. It's super important for our brain and eyes, that's why it's often added to baby formulas and recommended for pregnant women. Even for adults, DHA helps with memory, learning, and reducing inflammation that could lead to heart problems. Meanwhile, omega-6, like linoleic acid, is commonly found in vegetable oils such as sunflower or corn oil. It helps keep our skin healthy and support growth and immunity. But here's the catch. Too much omega-6 and not enough omega-3 can cause inflammation, so it's really about balance. Eating more fish, nuts, and plant oils in the right amounts keep our heart, brain, and body in good shape.